Yes. Okay. So in today's session, we're gonna talk about YAML for Kubernetes. Of course, last week's session was all about business. We took a step back from the technical perspective of Kubernetes, and now we're gonna jump right back into it. So also this week's session is a special session, so it was not uh, in the old plan. It was suggested by um, someone called Christian. He's a dear friend of mine, and the main purpose of this session today is to talk about YAML. It's where all the magic happens in Kubernetes. We're gonna talk about a lot of stuff today. So today's session is more technical than last week's session, which was all business. Okay, so we're gonna have a few things to talk about. The first thing, we're gonna have approximately 8 indexes or 9 indexes we want to talk about. So first things, we want to give a very introductory idea of YAML. What is it YAML? What do we mean by scripting? And what does YAML have to do with Kubernetes? And then we're gonna talk about declarative versus imperative model, and how does both models affect our Kubernetes journey and deployments. Also, the third index is going to talk about the autonomy of Kubernetes manifest. What do we mean by Kubernetes manifest before we go to the autonomy of Kubernetes manifest? And then the fourth one and the fifth one, we're going to talk about the actual components of Kubernetes manifest. I know it's a bit early. We're talking about Kubernetes manifest. Unfortunately, this is the table of index, guys. So we're gonna talk about API version, and then we're gonna talk about kind, metadata, and spec, which is specification. We're gonna understand what are these headers, and we're gonna talk more about them. So we're also gonna talk about Kubernetes resources. So what can we use YAML for? Not just creating pods, not just creating replica sets, not just creating deployments. It's more than that. We have typically a resource for any business case we want. So we're gonna talk about the common ones in networking, common ones in security and secrets, deployments, networking, and all that type of stuff. And then we're gonna see on how Kubernetes apply a YAML script. So we use it in a declarative state, and how Kubernetes actually use and apply this YAML script and auto scaling and all of that. And then we're gonna have a hands-on YAML lab. It's not gonna be hands-on. It's gonna be a bunch of questions, and all about them is how to write YAML, and just a mental building a mental model on how to write using YAML. And I'm gonna be sharing the lab questions. I think it's approximately 16 questions. So I'll be sharing the document afterwards. It's on my GitHub account as well if you want to answer it after the session. And then we're gonna talk about key takeaways and what's next. Of course, we're gonna have a next, not next week, but the week after. We're gonna talk more about it when we get to the index. So first thing, what is YAML in Kubernetes? So, I, as you all know, I don't like to read off the slides. I just like to have a good discussion with you guys. So, starting with YAML, YAML is a scripting language, and it's a very sarcastic one. Okay, so even the people who created YAML call it YAML ain't markup language. So even they don't want to say that it is a programming language or it's a scripting language. It's something very simple. It's human readable. It's very easy to learn as well, and it's also the number one it's not the number one scripting language, it's one of the used scripting language. You can not just write Kubernetes, you can also use it for Docker files, Docker containers, Docker Swarm, and Docker Compose files. All of these use YAML scripts, and a lot of tools and resources in DevOps use YAML scripting. So you need to have a very basic understanding in YAML. It's very easy to learn, it's human readable. You for Kubernetes specifically, we're gonna talk about it today. I'm not gonna be discussing YAML in general. Hopefully we can make a other session for that later on, but today it's gonna be YAML in Kubernetes specifically. So Kubernetes uses YAML as a scripting language to declare any type of resource, any type of pod, what kind of deployment we want to use. It all uses Kubernetes. Sorry, it all uses YAML, not Kubernetes. Kubernetes uses YAML, yes. So as we have in the end line here, it says YAML defines intent and Kubernetes handle executions. So we only declare what we want, we write, we script what we want using YAML, and Kubernetes makes sure that this is, as we call, done and dusted. So we're gonna talk about declarative versus imperative model, and this specific slide, the declarative versus imperative module, this is gonna talk about we have two ways into using. One is using YAML script, and the other is using an actual CLI commands to actually easier or implement the commands much faster than using a YAML script. So let's begin with the declarative model. So declarative model is basically our original YAML script. We're gonna have an example in the upcoming slides. We're gonna talk about. We're also gonna have in the next slide a very small example on declarative and imperative model. So declarative is actually the actual YAML script. So you only write it once, and Kubernetes applies it, and he keeps comparing the states. I don't want to go too much in that. We're going to talk about it in the upcoming slides. But declarative state is basically when we have things declared inside a YAML script, and that's it. So, imperative model is when you want to adjust something inside the Kubernetes script without actually accessing this Kubernetes script and having to manipulate or deal with Nano or text editors or Vim. So, you only write a command like set replicas to 3 instead of 1, and this is so much easier than just going through the YAML script trying to edit a replica or number of pods from 1 to 3. You just declare it using an imperative model or an imperative command where you actually tell the CLI to set replicas to 3. Here's a small example. So, declarative state is when you write a YAML file. As you can see here, we can see deployment.yaml file, and you apply this YAML file. So, this is the declarative state, and we're gonna see a YAML file or deployment YAML file in the upcoming slides. But I just want you to connect that declarative state is connected to a YAML file, so it has a YAML file. On the contrary, imperative model is actually just running commands. So, as you can see here, the first command is a kubectl or kubectl run my app on the image nginx. It's if you're using some type of I would guess Alpine nginx or Apache, and you just want the normal old regular nginx, you just specify that you want the image to be nginx without having to enter text editor to enter the YAML script or the YAML file and having to edit it, as well as the second line, which is kubectl expose pod to the port 80 HTTP. And this here tells you that I don't want to enter the YAML file, I just want to edit the port to 80, and that's what's gonna do. And the last one is the most used one from my perspective. So a kubectl scale pod my app and set the replicas to equal for 3, and this is the one used for replica sets or deployments if you want to adjust your number of pods. So the line here we have imperative is do it now, do it right now. And declarative is this should always be true. Okay, this is a really good line, actually, I like it. So autonomy of Kubernetes manifest. So um, we have discussed the actual YAML script, and then we have talked the declarative and imperative model, and now we're gonna talk about what do we call that? What do we call the deployment.yaml file? What do we call any kind of YAML file that is related to a Kubernetes resource? We call it a Kubernetes manifest file. So you manifest something, Kubernetes makes it true, so it's called a Kubernetes manifest. Yes. So think of a Kubernetes manifest as an ID card for a resource. Yes. So every resource has an ID card, and this ID card is called the Kubernetes manifest. It tells Kubernetes what this thing is. So, is this thing a deployment? Is this thing a stateful set? Is this thing a daemon set? Is it a config map? Is it secret? So, a Kubernetes manifest tells Kubernetes what this is, what this YAML script is doing, or what's intended to do. And it tells it how to behave, and the structure is always predictable, so Kubernetes knows exactly how to read it. Of course, we're going to talk about how to write a Kubernetes manifest in the upcoming slides. We have four main headers that from it comes everything else, and we're going to talk about every one of these header in more detail. So the four required headers, or the four required things you need to write in your Kubernetes manifest YAML file. The first one is API version, the second one is metadata, third one is kind, and fourth one is spec. Of course, if you want to go in order, it's API version, kind, metadata, and then the last thing is spec. Why we're gonna talk about it more. So the slides are very connected to each other. I don't want to burn any other slides, so let's use it. Okay, so in our fourth index, we're gonna talk about API version, kind, and metadata. Of course, I have left the spec or the specification in another index because it's a bit bigger than these three combined. The spec is, as it's called, specification. You specify what you need. So let's begin with API version. So API version, tell Kubernetes which API version you would like to use in the resource. So do you want V1, which is version 1? Do you want V2? Sometimes application use apps slash V1. So it's basically, typically we use V1. So API version, just you just only specify which version you want to run on, and that's it. A kind, it actually tells you, does not tell you, it tells Kubernetes what resources you want this file to do. Do you want it as a deployment? Do you want it as a replica set? Do you want it as a secret, a config map, ingress, service? So all of this you specify in the kind with only one word. So in the kind section, you specify the resource you want Kubernetes to deploy. And the third thing is metadata. Of course, metadata is the data about the data. And this here, we talk about labels, we talk about namespaces, we talk about any kind of metadata we want to add, like name, or if you want to relate it to another resource in the Kubernetes cluster. So, spec or specification, which is the most important section in the YAML file. In specification, you actually describe the desired state you want to reach. You want this Kubernetes cluster to reach. So you specify what images you want to run on. You specify the containers. You specify the ports. You specify everything. You even specify at some point the resources like CPU and memory. So the magic all happens inside of the spec or the specification header, and this header will help Kubernetes understand, yes, I want to run a pod, but what kind of pod, what kind of image you want to run on, what ports should be exposed, what memory it should use. All of this is going to be specified um, in the spec header. Here's a very good example of all of these four things combined together. As you can see here, we have these four required headers that we talked about, which is API version, kind, metadata, and spec. And as you can see in the API version, we have apps slash v1. So it's telling Kubernetes run on version 1. And then in kind, we have deployment. It can be any type of resources. We're going to talk about Kubernetes resources in a bit. And then we have a metadata, it's called a demo app. So this file or this YAML script has a deployment resource that has a name of demo app. And then now the interesting part, the most, it's the long part or the huge part, which is the spec part, where you set your replicas to 3. So it's in the deployment, you're going to have a replica set, which is going to make sure that you're running on 3 pods in all times. So this here comes Kubernetes in its full strength and telling you that it can auto heal, it can balance, it can help you with your workload. And then we have selector, which match labels to app called demo. And matching labels, these all are Kubernetes, sorry, YAML scripts that are connected to Kubernetes YAML scripting. So I'm not going to go very much into detail about YAML scripting in Kubernetes in that much, like matching labels and all that stuff. But this is typically saying that you need to match a label, or you need to match this resource to an app called demo. And then we have a template, and this also template is related to the app demo. And then you can see there's a spec for a spec. Of course, this is very funny. Spec for a spec. The other spec, the one that is down, not the one of the fourth required four. This spec inside of a spec is telling which container you need to run on. So is the container, you specifying the container, it's going to be running on Nginx latest version, it's going to have the port 80 exposed, and it's going to be called app container. And this is a very basic YAML script. It can go very much dark from here. It can go like secret scripting, which should be base 64. It can go to config maps, it can go to ingresses, it can go to services, as we discussed. Yes. As Conrad said, spec of a template spec. Okay. So, common Kubernetes resources. We have a lot of resources. We're going to talk about the common ones, uh, beginning with actually core workload resources. So, we have very four core workloads, which is a pod, the smallest unit inside a Kubernetes cluster. And this is a line that you're always going to hear no matter what. That pod is going to be the smallest unit running inside a cluster, and every pod can have a container, which is best practice, and maybe a sidecar if you need to. So what do we mean by a sidecar? It's basically like having some type of observability small container beside the actual working container to gain logs and metrics. We should have mentioned that in the observability session, to be honest, but fortunately we're mentioning it here right now. So best practice in Kubernetes is to have each container running one workload. It's not best to having like a pod running 2 3 containers. That's not best practice. It is doable, it's not best practice. But you can have one container per one pod, and you can have a sidecar with that container if it needs to. So it's like you can add fluid bit or something like that, something that needs to be inside the container. And then we have the deployment, which deploys a set of pods, and it can be manage these pods using replica set. It can help you with rolling updates or rolling back, and it can help you for self healing, as we talked in the previous slide. Of course, we have a stateful set, and stateful set, they manage workloads with basic and very stable identities and storage. Um, to be honest, I don't remember using stateful set for my business case. Never used it. I have used Damien set. Damien set is actually, I use it for to add CloudWatch and observability agents into my Kubernetes cluster. So Damien set, it just ensures that every pod runs on its selected nodes. So I've used we've used Damien set to actually tell Kubernetes that I want a CloudWatch agent, I want a Prometheus agent on each and every node, and this is where Damien set comes in place. And as we said, stateful set is just you need to run workloads or stateful workloads with stable identities and storage. Okay, so networking, and we have talked about these in depth in the networking session. We have services and ingress, and we have talked about ingress is where they manage external access to the cluster, and services is it provides like load balancing and routing to the actual pods. So we've talked about these as well. Okay, so configuration and secrets, we have for configurations, it's config maps, and for secrets is secrets. Of course, just a quick note that secrets won't apply if you like say kubectl apply minus f secret.yaml. It won't apply unless the secrets are actually encoded using base 64. You can't encode normal text or unciphered text or uncoded text without having to actually do the encoding one by one, and it's extremely a hassle. So for me, I generally use AWS Secret Manager, and I just connect any kind of workload. If it's using ECS, if it's using AKS, I connect it to AWS Secret Manager. It's really easy, it rotates on its own, and if you want to adjust any type of secret, it just update the secret without having any kind of downtime. So that's a very good idea of using AWS Secret Manager. I would guess other cloud vendors have the same thing. I think Oracle has the service called Vault, if I'm not mistaken. Vault has the same purpose as AWS Secret Manager. Of course, every cloud vendor has uh, their own benefit and all of that. So typically, secrets or config maps, they're used to separate configuration and secrets from code. Still, I don't think they're best to use, to be honest. Like we have, as I said, AWS Secret Manager, which can help us a lot more than secrets. Okay, so sorry, this is not configuration and secret. This is jobs and cron jobs. So this needs to be edited. So job is basically when you need something to run only one time, and cron job is the contrary. You need it to run on a schedule or a time-based schedule, like you want to take backup every day, or you want I'm trying to think of things I used cron jobs on. So I've used it on backups, I've used it on reports if you want to create any type of reports on the database. Um, you can use cron jobs for anything that you needed to be repeated. So if you want, for example, a cron job that actually takes files from another SFTP server, you can use that. Or if you want, like you have a marketing campaign, for example, every first of the month, you can use Kubernetes for that. We've actually did that for some reason. And a job is you just only do it once. So if you want to like update something once, take backup for once, or do something that is only one time, you use job. And if something with a schedule or a time-based schedule, you would use a cron job. Of course, it's very similar to bash scripting. So in bash scripting, you actually can configure cron jobs in it using cron tab, and kind of does the same purpose. So you can use both, I guess. Okay, so we're gonna come to the very important part, which is how Kubernetes apply YAML. So we've understand the very basic understanding of YAML. We've understand how sarcastic it is. If it's even called YAML ain't markup language. They don't consider it a markup language. They don't consider it a scripting language. I personally consider it a scripting language because I love scripting. I used to like code in Java, and then I stopped. And then we've talked about the four main required headers in Kubernetes files, which is API version, kind, metadata, and spec. We've talked about each and one of these. And then we've talked about common Kubernetes resources, and now we're gonna talk about how actually Kubernetes applies these YAML script. So when you apply a YAML script, so when we write a command called Kubernetes or kubectl apply minus f secret.yaml deployment.yaml, as we saw on the previous slides, it stores the desired state in the API server. So in our first session, in the beginning session, where we gave an introduction to Kubernetes, we said that there's a control plane or a main node or a master node, and then we have the worker node. So we're not going to be talking about the worker node, we're going to be talking about the master node or the main node. And we have the API server. So Kubernetes stores the desired state inside this API server. And then we have something called controllers. Controllers continuously compare the worker node states with the actual desired state that we need to have. So is this cluster actually running on 3 pods? Is this cluster actually running on 500 megabytes of CPU, or sorry, of memory? I'm sorry. So is it actually running the desired state that I declared using the declarative model inside of the YAML script? This is how Kubernetes applies YAML. So it stores the state and it keeps every time it keeps checking if this is actually what is desired, if this is the desired state. And you can see here in the last line, it says YAML is applied once and reconciliation runs continuously. So it keeps on comparing, it keeps on seeing, is this correct? Is this not? And you can see that when a pod actually crashes and it starts going into loop crash, it keeps generating the same number of pods you actually needed or declared inside of a replica set. So you can see if a pod starts crashing, it's gonna generate another one, and it's if this failed and it stops, it's gonna generate another one. So it's keep gonna continue to generate pods until you actually fix the issue. Which here we talk about self healing. Of course, Kubernetes is not gonna just solve it mysteriously. You need to go in. You need to solve, maybe it's a memory problem that's keep killing this pod, but at the end of the day, it's gonna keep on Kubernetes, they're gonna keep generating pods until you actually solve the pod, and it's gonna stabilize on one or the number of desired replicas you want. But this is how Kubernetes apply YAML in the very simple context. So does anyone have any kind of question before we go into the actual questions? Because I think here we're gonna talk, yes, here we're gonna talk about the hands-on labs of YAML script. I'm gonna be sharing my screen into another. Can I? Okay. So if anyone have any kind of question, please, you can raise your hand, open the mic, or you can send it on the chat, DMs, Q&A, until I actually open the slides. Okay. So, in this lab, I'm not gonna be solving any problems. I'm gonna leave it for you. We're gonna talk about it more. We're gonna talk about the questions. I'm not gonna solve them because these are for you. Okay. Muhammad, are you asking about the difference between them three, or are you just telling me stateful versus deployment versus naming set? I think you're asking about the difference between the three. Yes, difference. Okay. So deployments, they're generally used to deploy an application. They're used for a very regular deployment. We use deployments all the time. As for daemon set, as I said, daemon set requires you like set this you tell the node or the pod to run on each node that you specify. So if you have, for example, node 1, node 2, node 3, you tell, for example, if you have a Prometheus agent or you have something in relation to observability, so you put this Prometheus inside a daemon set, and then you tell this Prometheus, go ahead and stuck like a mushroom, go and stuck into each node. So it's not in Kubernetes or in managed Kubernetes. uh, it typically it load balances the resources. So you can, if you have, for example, node A, node B, node C, you're gonna see, for example, node A and B in one cluster or in one EC2 instance. I'm sorry, in one EC2 instance, and you're gonna see another, for example, node C. You're gonna see it in another EC2 instance, but they're load balanced and connected to each other. Okay, so I'm gonna repeat the example. If we have node A, B, and C in a managed Kubernetes cluster in the cloud, you're gonna see that A and B is gonna be on a separate EC2 instance, and node C is gonna be on another EC2 instance. You don't specify that; it comes via managed EKS because it load balances. It uh, uses this load balancing to utilize resources. And then I'm gonna tell you in Arabic now what's the difference as well. So this Damien set tells you, I want it to run on all EC2 instances uh, without any kind, like you specify it to run on each node. And then stateful set, it's a very stable deployment that, for example, deployments, if you go over the CPU utilization, it can actually go and take from the host. So sometimes, like in ECS, Elastic Container Service, you can see that the memory utilization is spiking up to, for example, 200%. So this means that it's either using two cores or two core CPUs, or it's using the host's actual resources. So sometimes deployments can actually go and take from the host resource more than you specified. So if you specify to only use one vCPU and it happens to be a spike in traffic, it can go and use more than one CPU. It can use two or three, and it happens a lot. But in stateful set, it's used for stable deployments, stable workflows, and stable traffic to use it on a very stable resource. فبالعربي الstateful set هي للأشياء اللي ثابتة، اللي عندها ترافيك ثابت ما بتغير. الديبلويمنتس ممكن ياخد من الريسورسز للاي سي 2 اللي تحتيها. يعني ممكن انه احنا نحدد باليامل سكريبت او بالاي سي اس تاسك ديفينيشن انه استخدم واحد في سي بي يو، ويصير عندنا سبايك بالترافيك يروح يستخدم like ثلاثة سي بي يو، يطلع عندك 300%, which is very normal. and in the mean set انت بتحكي له انا بدي هاي البود تكون شغاله على كل نود انا عندي اياها، على كل اي سي 2 انستنس انا عندي اياها، لانه كوبرنيتيز بالعاده وبالطبيعي هو بيقسم وبوزع الشغل based على الورك لود، based على الريسورسز. فانت you don't manage the utilization of resources, Kubernetes does. Yes, exactly. It's just simple code without any dynamic operations. Stateful set are used for DB pods. Exactly. Even though sometimes it's not best to use databases inside Kubernetes, I would guess, because we actually had a discussion about that, I think, in the last session. But you can use stateful sets for DBs, yes, of course. This is a very good example. Yeah. Okay. So, um, in this lab, you're gonna understand what a Kubernetes manifest represents. You're gonna identify the Kubernetes structure, and then we're gonna write a very basic manifest using the declarative model. And then the prerequisites to having that is you need to understand. Yes, thank you, Conrad. So DB not only relational but memory database NoSQL, yes, like MongoDB or any kind of NoSQL key value databases. Yes. So we're gonna have you need to have a basic understanding of Kubernetes concept. You need to be very familiar with YAML syntax, specifically in indentations, because believe me, I've had a lot of problems with indentations and all of that. So question one is, what is the four required top level fields in every Kubernetes manifest? We have been talking about this for a very long time, so I'm not I'm not gonna answer that. Question two, what is the role of spec field in Kubernetes manifest, and why is it considered the most important section? We've also talked about this, the spec or the specification. Question three, create a very basic deployment manifest that uses this, this, and this. This is in the, I'm not gonna say it's very obvious, and this is also very obvious. And also in the question, it specified the third field, And the last one, define two replicas, is where you define the fourth field. So you don't actually have to write the spec. You only need to define the replica number. So extend deployment by adding a container named web. The image is using Nginx, and the port that you're exposing is 80. Question 5 is update your deployment to scale from 2 to 4. Add a label and call it app. Which fields changed and which fields are staying the same. And this is for you. This is why I didn't want to go into the labels inside the session or anchors. There's a lot of things you can actually read about labels and anchors. So, what is the purpose of the labels and how are they used by other Kubernetes resources? Question 7, create a service manifest. We actually have created a service manifest. I think Maulik, yes, Maulik is here with us today, and he's the one who created our Kubernetes manifest in the networking session. So you need to expose port 80, you need to select the label of app web, and you need to use cluster IP. Okay, so question 8. Explain how Kubernetes knows which resources a service should route traffic to. This is also, we discussed this inside the networking session. If one pod crashes and you need to update the YAML script, do you need to update the YAML script? Why and why not? Of course, this is a very good question. If a pod crashes, do you need to update the YAML file? Why and why not? Can anyone answer that? Actually, I would love to hear your answers. This is a very good question. Question number.
Uh, for deployment, no, already will be a new one. Or what do you define a replica and deployment smith like three will be always will be three inside three running. That's why I wanna- that's
طيب محمد، لنفترض انه احنا اذا عملنا، اذا البود بلشت عنا تموت وبلشت تعمل كراش، هل احنا بنحتاج نعمل updating لليامل فايل ولا لا؟
في المانيفست لا بتكون هو بس بتكون اذا البوت اخترع اذا الدوب اعتقد الدبلومت بيشغله يعني اوتوماتيكيا يعني بيسوي ريبليكا جديد بداله.
ما هو
هذا على
بحكي لك،
فهم يعني.
اه هلا في منه الحكي، بس the first thing you need to take into consideration is actually to check logs before doing that. So why and why not? Both can be done. So either you need to actually update the YAML script، وهلا رح احكي لك ليش، or you don't need to add you don't need to adjust the YAML script. So if the pod crashes due to code problems, of course you're not gonna edit the or update the YAML script لأنه هاي مشكلة كود. You need the developer to actually go and update that code. But if a pod starts crashing because معنا resource، معنا CPU، معنا memory, it's using all of their resources. So انت حطيت 500 ميجا بايت ميموري وهو عم بيستخدم اكثر من 500 ميجا بايت ميموري والبود عم ضلها تعمل كراش، it keeps crashing. In this case, you need to actually go inside the YAML file and update the resources part and increase the memory resource. So instead of 500 megabytes, for example, you can add it to 1 gigabyte, or we can add more CPUs or vCPUs. And sometimes and these are the only examples I got on top of my head, but yes, you can update the YAML script and you cannot update the YAML script. It's based purely on logs, purely on logs. So you can't just decide that on top of your head until you actually go and check um, what is happening. Of course, sometimes when a pod keeps crashing, you can't enter inside the pods and get the logs, and this is where observability comes in place. So we all know, if you ever dealt with Kubernetes, لما البod تبلش تعمل crash, you cannot connect, you cannot exit inside this pod and get logs. So you have a Prometheus agent scraping all of these logs. You have a Loki agent, and then you have a dashboard that will show you historical data, maybe on AWS ECS as well. You can connect it to CloudWatch groups, CloudWatch log groups, or you can actually check log and event tabs in AWS. So In your own word, explain the difference between declaring desired state and executing commands imperatively. We've talked about these. We gave also very small examples on these. And what happens if the API version specified is not supported by the cluster? So, if you're using AWS, you can actually see the version that the cluster is running on. So, what would you think it would happen if you were running on a very different API version than the cluster is supporting? This is a very nice thing to try, actually. Not even on AWS, even locally, you can know what kind of version your cluster is running on. So, why does the deployment require both? Why does it require a selector and a matching label inside templates metadata.labels? What could go wrong if they don't match? I love this question. I had a lot of problems using using labels. I still, to be honest, I still have problems using labels and selectors. It's very easy to understand. It's just gets complicated when you're using it with Bitbuckets and Bitbucket pipelines. It's just exhausting at this point. So, which part of a Kubernetes manifest are user defined and which parts are managed by Kubernetes? Hint, think about spec versus statuses or status. Sorry. So, very nice question. I actually love that question. Yes. Uh, what would happen if you manually delete a pod that is managed by a deployment? Explain your answer using the concept of reconciliation. Can anyone answer that question? Because we actually talked about the session. I accept chat answers as well. Okay. Also, we have another question, which is why YAML indentation is critical inside a Kubernetes manifest. What kind of issues can incorrect indentation cause? Of course, you know it's best practice to use spaces, not tabs. Even though personally I use tabs because it's just easier than keep hitting space. But uh, YAML scripting is an indentation like Python. It does use indentation to work its script. And then where would you define environment variable for a container inside a deployment manifest? We've also talked about these. Pod will be recreated. Question 14, deployment. Pods will be recreated. Wait, actually forgot. Yes. Yes, exactly, Conrad. Pods will be recreated. So if you ever used Lens, I'm gonna actually type this on the chat, which is a cube. This is a tool that actually it's a GUI for Kubernetes. I've used it. It's a very amazing tool to use. I'm gonna send it over on the chat. It's called Lens, and Lens is a Lens IDE. Let me send the link. Okay, copy link address, and I'm gonna send this to you guys. So Lens is actually a GUI. It's open source that connects to your Kubernetes cluster, and then it gives you a GUI visibility on it. And I used to use it when I want to deploy to delete pods, so it can actually take the desired state. So if I edit the YAML file, if I increase the size and the pod did not take the change, I would delete it. And no worries, it's not gonna go anywhere. The replica set or the API server, it's gonna keep checking statuses and it's gonna deploy another one in a very few seconds. So Conrad, yes, exactly. It's gonna actually recreate the pod. And as you said, deployment has a desired state based on number of replicas. It has a desired state on everything, not just numbers of replica, but very good job. So what is the difference between changing a value in a YAML file and running a kubectl command that changes the same value? How does this relate to declarative configuration? And then the last thing is when troubleshooting a non working app, why checking the Kubernetes manifest is often the first step? Very good question. Just like K9s in a terminal, but this one is for GUI graphical. Yes, it's actually yes. I did not like K9s because it did not give me the GUI I was looking for. It's useful for it's useful, to be honest. It's not, I'm not saying it's not useful. It's just I preferred Lens because you can adjust a lot of things. You can decode base 64 secrets. It can show you all of the environment variables that the pod is fetching. It can help you in a lot of areas, and it's also very user friendly. And you can connect multiple clusters in one view. So I genuinely like using Lens, to be honest. Okay, so I think let's share this tab instead. We've talked about index 8, and I got a few things. So we have a question. Hi, is Lens IDE can be useful for monitoring via customized kubectl for a managed one or two AKS clusters? So to be honest, the way I used Lens IDE is I used to have two clusters. Um, Also, so I used to have two clusters, one for prod and one for dev. And of course, having two clusters in AWS managed clusters, it's very hassle to just having an overview for them. So I just connected them via Lens. And connecting these two clusters via Lens using, of course, keys, access keys, it shows you multiple things. It shows you the deployments you're using, the stateful set you're using, the daemon set you're using, the network, the services, the ingress, the secrets, the workloads, the replica sets. It shows you everything you need inside one view. So I think it's just not, you can monitor on it, but not Prometheus, Grafana, Loki tempo monitoring. Rancher is great too. Yes, Rancher is actually very great. I have never used Rancher. I read about Rancher actually. I've got a lot of recommendation to use Rancher, to be honest. So I want to use it at some point. No problem. No problem. Okay, so key takeaways. So let's give a very quick recap on what we have said. So Kubernetes uses YAML manifest to declare the desired state. Each or every manifest allow follows a very clear structure, which is the four required fields, the API version, the kind, the metadata, and the spec. And YAML is declarative, it's not command driven. Once you apply a YAML script, you have to go and edit it if you want to do any kind of changes. And then Kubernetes continuously reconciles the actual state to match the manifest, so using the API server and controllers, as we said. And then common resources are pod deployment service config maps, secrets. We've also talked about services and ingress. Daemon set and stateful sets are just different shapes of YAML scripts. Once you understand the structure, reading, writing, manifest becomes very predictable. So they all follow the same structure. And if you can read YAML, you can reason about Kubernetes, of course. And guys, I just want you to answer this question. So, using this session, even if I didn't explain YAML, it was very human readable. So if I showed you the YAML script, you'd understand what we're talking about if you understand Kubernetes concept. So YAML script is one of the most um, needed skill besides Linux and Bash scripting. It's one of the most needed skills to actually read JSON scripts. You need to read YAML scripts. You need to read Bash scripts. So if you're able to read and understand these scripting languages, even programming languages, at some point, it would help you so much in debugging, in deploying, in every kind of perspective you're trying to use these tools. Not just in Kubernetes, in every kind of tool, in Terraform. If you're writing on AWS, you need to understand JSON scripting. If you're using Docker, it's also written on YAML. So Terraform uses like a syntax close to JSON. It's kind of like JSON. It's just .tf. And we're gonna talk actually about OpenTofu. OpenTofu is also infrastructure as code tool. I'm genuinely interested in that topic. So next session, which is on February 15th, we're gonna have a lightning talk. So this is the last session of Kubernetes fork from Terraform. Yes. So um, this is the last session of Kubernetes month. Hopefully, we can redo another Kubernetes month, but in more detail, more intermediate, more advanced level. This was a very introductory level. I'm gonna stop my recording